Hi, good morning. We are doing today 8.5, which is using the distributive property. So you guys have been learning how to multiply polynomials and monomials together. And so today we're going to do something with the distributive property. But we're going to start our journey on something called factoring. So factoring is going to be like your best friend later, especially when we get into quadratics. So take a look with me. Here's what we have done in the past. So if you were to solve this, you would probably say, hey, all I would do is take 4a times 3a, 4a times 4, and we would get 12a squared plus 16a. And you would be done. You would have used the distributive property to simplify the problem, right? So now what we're doing is we're taking that answer and saying, how can you use the distributive property backwards to factor the problem? So what you need to think about now is, what is a greatest common factor of 12 and 16? So you can run through your factors, things that go into it, that are divisible into it, and the greatest common one would be a 4. And then you need to look at your variables. What do they both have in common? They both have an a in common. And so then you would say, okay, well, both of those are the greatest common factor of both of those terms. And you would be able to say, I'm taking a 4a out of both of those. So then I'm left with a 3a plus 4. And that would be how you would factor that problem. Another way to think about it is to write out the factors of these numbers here. And so you would say a 1 goes into that, a 2 goes into that, a 3 goes into that, a 4 goes into that, a 6 goes into that. Let's see, 1 and a 12. Let's see, 1 times 12, 2 times 6, 3 times 4. And then you have an A and an A. And then also a 1 goes into 16, a 2 goes into 16, a 4 goes into a 16. And then we think about the multiples there, 4 times 4. I don't need to write a 4 again. 8 goes into it, and a 16 goes into it, and then an A. So what you're looking for is the greatest common factor, and the greatest common factor is a 4, and they both have an A. So that's how we end up with this number outside of the parentheses, is that it's the greatest common factor. Let's look at the next one. So now we can probably just think about it without writing it out. So 18, 12, and 9. The biggest number that goes into all of those would be a 3. And then now I need to look at the C's. What's the largest amount of C's that I can take out of all of them? The same C, right? So C's would be 1 C. If I look at all these, they each have 1 C, so I can take a C out. And then the D's, this is D to the second, D and D, the most amount that I can take out of every single one of them would be a D. So now I'm going to tell everybody, hey, I am taking out of every single term from this trinomial a 3CD. So 3 into 18 goes 6. My C's simplify to be a 1. My D's just become 1D. Then 3 goes into 12 4 times. C into C is C. And my D's simplify to be a 1. 3 into 9 is a 3. C simplify, D simplify. That's awesome. And here you have your factored form of that trinomial. Pretty cool, huh? So let's look at the next one. Maybe you could pause the video and try it on your own, and then start the video again and see if you got it right. Okay? So I'm going to look here, 12, 24, and 30. Well, 12, 24, I would think 12, but then I've got this 30 at the end. So it has to be a 6. Goes into all of those. Then I look at my x's and my y's. The max I could take out would be an x. And then the max I could take out of the y's would be a y. So I'm telling everybody, hey, everybody, I'm taking out this 6xy from all of those terms from this trinomial. So 6 into 12 goes 2, x's simplify, y simplify. 6 into 24 goes 4, x simplifies, y, there will be 1 left on the top. 6 into 30 goes 5, 1x stays, and if there's 1 y on the bottom but 4 on top, I get 3 that stay there, and then I'm done. One thing that you might want to just take notice of is that if you take something out and you end up with something that has common factors in your parentheses, then you didn't take out the greatest common factor. So just be forewarned of that you're going to be wanting to look at your answer. So this is kind of what happened as far as taking greatest common factors. This is shown in your book if you want to look at it. But let's move on. So that was using the distributive property to be able to factor. So next we're going to think about a previous concept that we used, and that is if you have 4x and you have 3x and you add them together, don't you just have 7x? And then same thing here, if you have 4a and 3a, don't you just have 7a? In our next concept, this is going to come into play, where the 4 is multiplied by something, and the 3 is multiplied by that same thing, and what's going to happen here is really we're adding the coefficient. So same down here with the a's. 4 is multiplied by an a, 3 is multiplied by an a. So what's going to happen here is that we add those coefficients and we get 7a. But the a stays the same and the x stays the same. So let's look at our next concept. This is called grouping, and it's factoring by grouping. So whenever you see terms, there are 1, 2, 3, 4 terms here, you can use this strategy called grouping to simplify it. So what that means is that you are looking at two groups within the polynomial. The first group would be here, and the second group would be here. It doesn't mean that I'm multiplying them, okay? It just means that I'm grouping them together in my head. And the reason why is because there is a common factor that we can take out of those two terms. And that common factor, the greatest common factor, is a 4 and a 4. Now I look at the variables. Is there a greatest common factor of the variables? Well, they each have a b. So using what we learned just a second ago, we can rewrite this as 4b parentheses. That will simplify, that will simplify. I'm just left with an a plus 2. That will simplify. That's all I'm left with there. Now I look at the second two terms and I say, what can I take out of those? What's the greatest common factor? That would be a 3 and a 3. So I'm going to show I'm taking out a positive 3. And once I take out a positive 3, I get an a plus 2. Now, you've got to look at what we did in the screen before, because look what's here. Both of those terms, or maybe we'll call them coefficients now. Well, they're not in front of a variable, but It's the product of something that they're multiplied by the same thing. So look what happened before. If we had the same thing and we were multiplying, we just added the things in front and we kept the same thing that we multiplied. So this is what grouping is. You take the things in front because they're both multiplied by an a plus 2. So you can say, I've got a 4b and a positive 3, and they are both multiplied by an a plus 2. And that would be your solution, okay, or your simplification. Now what's super cool about this is that say you're unsure that you are correct in doing it. So you can always check. If you go back and you FOIL or multiply using the distributive property, you get 4ab plus 8b plus 3a plus 6. And then look at what you have there. Okay? So this is factoring by grouping. We just double checked it, but our solution is right here, or how we simplified it by grouping is right there. So look at the steps here with me. Group terms with a common factor. Factor out a GCF from each group, okay? And then you are going to group those things in front together to write a product of two binomials. Let's look at another one. And if you want to pause it now and try it on your own, great. All right, so I'm going to look at these. I'm going to group them together. And then what's the greatest common factor of both of those? So it would be a 4b. 4b. 4b, I'm taking out, and I'm left with a b minus 3. Now look at this. 2b and a 6. I'm going to take out a 2. But I'm taking a positive 2, so I'm going to write a plus 2, and I'd be left with a b minus 3. Now, I have the same thing in parentheses here. And if you don't get the same thing in parentheses, then either you've taken something, you haven't taken the greatest common factor out, or maybe you need to group it differently, because we don't always have to group the first two and the last two together. You can rearrange them to find something that will group together to work. Okay, so now all I have to do is take these, 4b plus 2, and multiply by b minus 3, because they're both multiplied by a b minus 3, so I can group it together. And then you can go ahead and check if you want. So 4b times b is what we have here. 4b times a negative 3 is what we have here. 2 times b is what we have here. And 2 times negative 3 is what we have here. Okay? Now, of course, there is a little bit of a twist. There always is, right? Because we need to be prepared for different problems that may throw curveballs at us, right? So let's look at this one here. We are going to group it again, just like we have in the past. We're going to look for the greatest common factors. So 2 and 2 and m and m. So I'm going to take this out. 2m. That would all simplify. I'd be left with a k minus 6. That simplifies. So a k minus 6. Oh, great. All right. And then over here, let's see, the greatest common factor would be a 7, right? So then I'm taking out a positive 7. And I would get a 6 minus k. Oh, all right. Well, we did not, it kind of looks similar, but if you look at the k here, it's positive, If you look at the k here, it's negative. If you look at the 6 here, it's negative. If you look at the 6 here, it's positive. So we can't group anything together unless it is exactly the same. It has to be the same thing that you're multiplying by. So how can we switch it? It's just the opposite of one another. Well, here is what we can do to make it the opposite. Instead of taking out a positive 7 here, what if instead we took out a negative? Dividing by a negative, so that means I need to erase this right here. Now I'm going to take out a negative 7. If I divide by a negative there, I get a negative 6. If I divide by a negative there, I get a positive k. So now I actually have the same thing in parentheses, and I can group these two things together to be 2m minus 7 multiplied by a k minus 6. And there it is. Again, feel free to check it. If you do 2m times k, I get that. If I do 2m minus 6, or 2m times a negative 6, I get that. If I do negative 7 times k, I get that. If I do negative 7 times negative 6, I get a positive 42. Isn't that great? All right. How about you try the next one on your own, stop it, see if you can do it, and start it again when you're done. Here we go. I'm going to try grouping the first two and see what I can take out. I can take out a 2 and an x for each of those. So I would get a 2x and then a, let's see, y minus 5. And then over here I can take out a 3. So it would be a positive 3y plus 5. Oops, Mrs. Rodriguez forgot that negative on the y. All right, so again, I see that I have exactly the opposite of what I want. If I would have caught it early, I could have just taken out a negative, because you can start thinking ahead of the game. You can see that the first two terms here are negative, but the last two terms here are positive. So when you take something out, you're not going to get the same thing. So you can think ahead and say, nope, I'm going to take out a negative so I can get the same thing. So now we have the same thing. We can group these together. Negative 2x plus 3 multiplied by a y plus 5. And we got it. All right, you guys, you have a homework assignment for me, and it is page 524, 15 through 27, and 46. Hope you guys are doing well. Miss you, miss your smiling faces, and see you tomorrow.